Hi, Simon here, GM8NYV. Just continuing on with my Denco coil project that I started a while ago. It's been sort of slow progress, what with other things. My intention was to replicate Denco coils that the guy F.G. Rayer used to design a lot of stuff for practical wireless. This is one of his designs, and it's in the was in the December '73 issue of Practical Wireless. 1973 was a long time ago. I always fancied making this. It's only a 3-band set, so the coils are used for the range 5, 4 and 3 T. Made my own formers, 3D printed them, and then I decided to replicate the Dencos. Now I managed to get hold of original T5, which is this one, which is quite clean, good condition. Then I found this one, which turns out to be a T4. I worked it out from the pin 1 and used pin 4 as the other pin for the main winding. Now you can see it's been well and truly it's been in the wars anyway with a soldering iron. Somebody's had looks like they've had a plumber's soldering iron there, something heat up with the iron. So anyway, so I managed to count the turns on it, and I can make a replica of that one. Now for the T3, I didn't have a red 3T. I did have this in that set of stuff I got. It's a white 3, as it turned out, a white 3T. Now then, the white was used for radios or designs that had a 1.6 megahertz IF, whereas these are red ones were for 465 kilohertz IF. So it gave me some idea of where the windings were, you know, the main windings and the tertiary windings on it, and where they position them. So these are, that's a 5, and this is my 5, my replica. I followed it as closely as possible. The 4 also, that's the original 4, and this is my replica 4. Tried to copy it as close as possible, the windings. And when it comes to the 3, because these had multiple layers and they used weave wound, I couldn't really do that, so I just pile wound this one. The 2 feedback windings, one on the top and one on the bottom on this case, which is the same as that. The feedback windings on the 5 are all both at the bottom, one on top of each other, same with the 4. Now as it comes to the cores, this is the original iron core, dust iron core. They're probably manufactured using dust iron and epoxy under a very high pressure. Now I can't produce the high pressure, but I did manage to make my own. Now I made my own by using a little mould. It's an 8mm. This is photographic paper, a normal printer photographic shiny paper, and I put the shiny side on the inside, wrapped it round to make a former for the 8mm, and it came up with a little tube. Got tape on that one, and these are the 2 formers that didn't print very well. I then put, that's the bar running through it. I then pushed that on there, packed it as best I could with the mix I made. It was 80% carbonyl powder, 20% epoxy. Now this is the carbonyl powder. So I hope it upside down anyway. And it looks a bit like this. Just looks like fine dust. Now the results when I tested it aren't as good as the original. Right, this is the Denco table of the red and the yellow. The nominal value in microhenries. These here for these 3, 4 and T. So I'll test mine and see if they compare to the originals. I'm going to use a nano VNA to measure the inductance. Now this is a crude test jig I made. It's 151 PF capacitor. I'll stick that on there. And those ends there I'm going to stick on here. Now the overall capacitance, the lead and this 150 comes to 208 PF. So basically this coil is going to see 208 PF across it. Now I know I can move the test point or the measurement point to the end by doing a delay, but when I tried using the delay on this I got some funny results. So I'm just going to keep it as standard and use this capacitor and the lead, which comes up to a parallel capacitance across it as 208. Now then, the pins to put this on, pin 1 and 6. Now it's given I've centered the core. At the center of the core I tuned it to get the lowest frequency. That means the core is in the center of the coil, and I've got a frequency of 7.27. If I move it either way, the core, the frequency will go up. So I've got 7.27. Now then, there's a formula for working it out, but there's an easier way. So I'm looking for inductance. Now we can read that. 208, that's the capacitance across it. And it came to 7.27. And here it works out the microhenries for you, which is 2.304. Okay, that's for the range 5T. You can see this. My range 5T is 2.45, so it's very close. Not perfect. Now what I'm going to do now is swap that Denco 5T, my 5T, right, let's have a look. Now this is my 5T, pin 1 and 6, very nice peak there. I used the same core, took the core out of the commercial one and I stuck it in mine. And centered the coil is now 7.16 megahertz, which is slightly lower than the other one. But when I put that into the calculator, right, so I've got 7.16 megahertz or 208 PF. The microhenries is 2.375. Now let's have a look on our chart here. And for 5T, 2.45. So not a big difference. Little difference, it could be the lead, all sorts of things. So it's very close to the original. Right, these are my replicas, the 5, 4 and 3T, and these are the originals, the 5, the 4, and this is a 3T but a white one for 1.6 megs, so it's slightly different to this. Right, I did a comparison of the three I made. My original 5T red, I worked it out to 2.3 microhenries. According to the instructions, it's 2.45. When I put my replica on it, I had a 7.16 megs, same capacitor, and 2.375 microhenries. Again, it's 2.45, so it's very close. Again, with my 4T, were 2.3 microhenries. It should have been 2.65, whereas the original was 2.634, so very close to the original. Mine's slightly off from the original. Going on to the 3T, the white 3T came in at 12.67 microhenries. It should be 13.6 microhenries. The replica 3T red came in at 21.14 microhenries, whereas according to the data sheet it should be 20.6. So they're not too far off really, and I think I can use those in the design that I want to build. Well, I hope that was of interest, and next time I'll show plans of my build of FD Ray's 1973 design of his 3-band radio.